In this lesson, we're going to talk about similar triangles and some of their properties and the postulates and theorems that are associated with the similar triangles. Remember, similar means that the angles are the same, okay? So both of the shapes have, and in this case, we're talking about triangles, they have the same angles, all right? And they also have, but they have a different size, all right? The sizes are different. One's bigger than the other, all right? So, and also remember that this little symbol there, that little tilde there, means similar to, all right? The different properties that we have, the reflexive, symmetric, and transitive property of similarity, which mean exactly the same as what they did for congruence, all right? And the one postulate that is different than what it is for congruence is that you actually have an angle-angle postulate for similarity, which basically just says that if you have two angles that are the same or that are congruent in both triangles, then the triangles are similar, because that would mean if two angles are the same, the third angle is also going to be the same. Another theorem that we have with that's sort of the same thing as congruence is the side. But remember, the congruence theorem said that all three sides have to be the same length. Well, in similarity, the objects are different shape or different sizes, so they don't have to be the same size, but they have to have the same ratio. Okay, so in this case, JL would have this the ratio of JL to MQ would have to be the same as LK to QP and JK to MP. So all three sides, the ratio of all three sides has to be the same. And for the side angle side similarity, once again, the sides have to have the same ratio, and you have one angle that is congruent or the same. Okay, so copy all that into your notes. All right, so this is just a small table here showing all three of those, the two postulates or the two theorems and the postulate associated with similarity. Okay, so this is, it says determine whether triangles are similar and identify which postulate can be used to prove similarity. Well, obviously you see here, here's an angle that's congruent between the two, and here's a second angle. So this would be angle-angle. All right. This, well, we have an angle right here, a right angle that's congruent, and you have sides that are on either side of that angle. So we're going to check to see if the sides are have the same ratio or are proportional. So we have 20 over 18. All right. If I get my graphing calculator out and do the graphing calculator to reduce that, I go 20 divided by 18, math, enter, end up that reduces down to 10 over 9, all right? So that's 20 and 18 right here. And so then you have, because we did the 21st, we have to do the 36 on top, 36 over 24. Without using the calculator, we know that 12 goes into both of those, all right? So 36 divided by 12 is 3 over 2. So these are not the same ratios. So this triangle is not similar. Okay? Because the ratios are not the same. All right? Well, what about this one? Okay? Once again, the angles are the same. We're going to do the ratio 24 to 16. 8 goes into both of those, so we reduce it by 8. So that's 3 over 2. All right, and then we're going to do 39 over 26. All right, 13 goes into both of those. So we're going to do 13 and 13, or you could also use your calculator to do that. 39 divided by 13 is 3. 26 divided by 13 is 2. So these are the same, okay? And so we know that they're similar by side, angle, side, okay? So this is side, angle, side. This obviously has all three sides that we're going to compare. We're going to see if all three sides have the same proportion or have the same ratio, then it's going to be side, side, side. But we have to check to make sure that they're the same ratio. Okay, so we're going to do 32 over 20. All right. 4 goes into that. Okay, so we're going to divide by 4. So that would be 8 over 5. All right. 24 over 15. That reduces by 3. Okay. Reduces by 3, which gives us 24 divided by 3 is 8. 15 divided by 3 is 5. Okay, so this is looking pretty good. And 40 over 25. Okay, so 5 goes into both of those. Okay, so we're going to divide by 5. And once again, we end up with 8 over 5. So all three of these are the same ratio. So that would be side, side, side. All right. So the next thing that we're going to do is we're going to use the fact that similar triangles have the same ratio of the sides to figure out what the length of different sides are. Now, in all of these examples, the triangles and stuff that I've used are understood to be similar. So we're going to write the ratio, and we have to use the same ratio. I usually say in this case, I'm going to do the small triangle over the large triangle. Okay, so that would be 10 over 20. All right, 10 over 20 is equal to, so we're going to write a proportion, 13 over x. All right, and remember, to solve a proportion, you just cross multiply. So that'd be 10 times x is equal to 20 times 13. All right. So 20 times 13 is 260. And you end up with 10x. Then you divide by 10. And you end up with x is equal to 26. All right. We can use our calculator to figure out some of these numbers, and we'll need to do that on several of the ones that are more complicated. Okay, so in this case, this looks a little bit weird, but we have two triangles here. Okay, we have this small blue one here. Okay, so we're going to do small over, and then we're going to do a large triangle. The large triangle would be from G to U to I and back to G. Okay, so if we're looking at the ratios, so the small here, the small triangle, the blue one, is 26 over, and then the large, so you're going to have to say the large would be this entire length here. So you're going to have to say 26 plus 13, which is 39. Okay. All right. Is equal to, and this side here, the small triangle is 20 over x. Okay. So then we're going to cross multiply again. So that's 26 times x, or 26x, is equal to 20 times 39. All right. So 26 times x is equal to, and if I do the if I do 20 times 39, I end up with 780. Okay. All right. So, and then we divide by 26. All right. And so we have 780 divided by 26 gives us 30. Okay. So x is equal to 30. All right. This one, okay, once again, we have, it's a little bit different shape, but we have two triangles. We have this one here. Okay. That's the one. And we have, that's a small one. So, and then we have the big one here. Okay. Right there. And once again, we know that they're similar. All right. So the easy one to make the connection here is the 30 and the 60. I'm going to do small over large, and I'm just going to do S over L, is equal to 30 over 60 is equal to, here the X is on the small one, so we're going to do X over 38.6. All right. Let's see here. So then we cross multiply. So we end up with 60x is equal to 30 times 38.6. All right. I'm going to multiply the 38.6. So I'm going to say 30 times 38.6 is equal to 1,158. And we know that that's 60x. So we're going to divide by 60. Which gives us 19.3. Okay. So x is equal to 9. Let me close this out. X is equal to 19.3. All right. So sometimes we don't end up with nice, easy numbers. Sometimes we end up with a decimal. Okay. All right. So this one is also slightly different. Okay. And just so you guys know that every one of these examples, you're going to have something like this in your classwork. Okay, so we're going to go small to large. Well, okay, so the small is, let me get the highlighter. The small is this one right here. Okay, we know that this side right here, over here, is x, but we don't know what the length of this side is. What we do know, though, is that the whole length is 24, and this additional part for the large triangle is 8. So we can say 24 minus 8, which is 16. So we know that this side over here is 16. I'm going to rewrite that in black so that we know that that's 16. All right. So we know that we can have the small one is 16 over the entire length, which is 24, is equal to x over, and there again, the complicated part about this is that it's not just 9, it's this x part plus 9. Okay, so we have x plus 9. All right, so this has got several different complications to it, but it's, if you think about the small one, what is it about the small one and the large one? It makes sense. So cross multiply here. 24 times x is 24. X is equal to 16 times x plus 9. All right. Remember, we have to distribute here. Okay. So that's going to be 16 times x is 16x plus 16 times 9. Okay, so let's see what 16 times 9 is. 16 times 9 is 144. Okay. So that's 144. We have 24x here. Okay, so to solve this, we just subtract the 16x, subtract the 16x. Those cancel out. We have 8x over here is equal to 144. I'm going to divide it by 8. Okay. So we're going to say 144 divided by 8 gives us 18. Okay. All right. This calculator is very small, so it's hard for me to see it. So x is equal to 18. All right. The next one is also another one like you're going to have in your classwork. Okay, and you're going to, it's got some complications to it. Small over large, right? Small over large. I always like to write that down. So that's, the small is 8 over the large, then is this 8 plus the additional 2. Okay, so we're going to add those. So that would be 10 is equal to 2x plus 6 over, now, we have two binomials here. You have this 2x plus 6. We have the additional x plus 2, so we have to add those. So the 2x plus the 1x is 3x. 6 plus 6 is 8. Okay, 3x plus 8. All right, so cross multiply. We have 10 times 2x plus 6 is equal to 8 times 3x plus 8. Now when we distribute, 10 times 2x is 20x plus 10 times 6 is 60 is equal to 8 times 3 is 24x and 8 times 8 is 64. All right. So when we solve this, we're going to subtract the 20x from both sides. This cancels. We're left with 60 over here. We're left with 24 minus 20 is 4x plus 64. So then we're going to subtract the 64. Okay, this cancels. We're left with 4x. 60 minus 64 is negative 4 divided by 4. So we end up with that x is equal to negative 1. Well, you might think, wait a minute. You can't have a negative number for a side length, okay? But this is not a side length. X, this is the value of x. X is equal to negative 1. And so if we were asked to figure out what the side length is, we could say 2 times negative 1 is negative 2 plus 6 is 4. So that side length there would be 4. And negative 1 plus 2 is positive 1. So that side length there would be 1. All right. But yeah, sometimes you might end up with a x value that's actually a negative number. All right. And once again, this is another one very similar to what you're going to have in your classwork. Okay. So we're going to have 6 over 14 is equal to, the small one here is x plus 2. This is small over large. Okay. X plus 2, and then we have to add them together. X plus 3x is 4x. Negative 3 plus 2 is negative 1. And then just cross multiply. All right, so we have 6 times 4x minus 1 is equal to 14 times x plus 2. Okay, and then solve it here. 6 times 4 is 24 minus 6 is equal to 14x plus 28. All right. This is 24x. I forgot to put the x down. So I'm going to subtract the 14x here. Cancels out. And I'm left with 10x minus 6 is equal to 28 plus 6 plus 6. 10x is equal to 34 divided by 10. And we see here that we're going to end up that x is equal to 3.4. Okay? All right. And so once again, we end up with a decimal number for our value of x. And then if it asks us to plug it back in to find the length of the sides, you just would plug in 3.4 into x, and so 3.4 plus 2 would be 5.4. And then you can do the same thing for SV and just plug it in for x. So anyway, that's the way you do this particular lesson on similar triangles. Ask me any questions if you don't understand something, and we'll talk to y'all later.